Alright, in this video I'm going to show you how to make some custom tools in Vision. And we're going to start off by talking a little bit about the tool before you bring it in. There's a couple ways. One way is to make your DXF file with a tool that you may have, or your tool manufacturer may have this file. And you can bring this into Vision and use this for your tooling library. This is a very nice method, almost preferred, especially if you can get the drawing from the manufacturer so you know it matches your tool. But the one key thing to note here is that you must have your origin point from the CAD model in between here on the tang. I'll zoom up into here. So in the middle of the tang here, and even with this surface, that's where the origin is on all these American style tools. So be aware of that. Very important. And if you do get a file from a manufacturer, ensure that it's in inch, especially if your Vision is set to inch. If you get a metric one, it's going to import at the wrong size. So prepare your file here, and we'll get ready here, and I'll show you the several ways that we can add a tool to our Vision library. Okay, here in Vision now, I'm going to show you a couple ways we can bring in a custom tool into the Vision control. We're going to go over here under the Tools Setup. Okay, and if this one I believe is password protected, I don't show it because I'm on a desktop version, but if you do need a password, the user password is 1701 to gain access into here. Okay, so once you're in here, let me point out here real quickly that my screen looks a little funny because my monitor is very wide compared to what's on the machine. That's why I see this funny tab over here. Normally my screen comes to here. So if it looks funny, worry not. This is just my monitor. So in our tools menu here, you've maybe seen this before. This is our typical punch inventory, and we have some for the die inventory and so on. And we got these three guys here. Custom punches. Okay, and if you don't have any, that's what we're going to show you how to do, is put some in there. And the same applies for the custom dies. First step, let me show you the tool generator. This is a nice easy way. If you don't have a CAD model, you will have to measure your tool accurately, and you can enter dimensions in here. Let me start from the beginning here on this tool generator. This will create basic shapes. So if you have a basic tool, any one of these, we can create it very quickly by just entering a few variables here. So I'm going to hit this straight first, and it's going to come up with this window. And you'll see what it has, some stuff filled in, custom straight punch. You can change that name if you like. It wants to know what style it is, American. And tonnage per foot. This is important to put in. Don't ignore it. And try to keep it accurate. This is to keep you from creating problems. Don't put in 150 tons, because that would be per foot, and there would be nothing to protect you if someone tries to overload it. This will keep you from putting too much pressure onto a tool that that could easily exceed the tonnage limit and break. So if you don't know the tonnage per foot, you can call the manufacturer of your tool and get a number from them. They can tell you. And then sometimes you can look it up in catalogs, tool catalogs. They'll indicate tonnage per foot on certain tools as well. So check with your manufacturer on that. Manufacturer, if it's a custom one that you made yourself, you can make up a name, or or whoever it is that you actually purchased your tool from. So down here are the parameters. There's not many. You see a basic shape here. This indicates the clamp, whether it's manual or hydraulic. So it's got a working height. Okay. And when I click on that, you'll see it indicates a little visual here indicating that's just the tool of the height of the tool. And so you'll enter that. This is a critical one. We want this to be accurate. So when you're measuring your tool, reverse engineering it, ensure that you're measuring squarely with your calipers, or maybe even use a granite table with a height gauge to accurately measure it. So you want to measure within a couple thousandths, so you got to be accurate. We have our tip angle that we could put into here. That's easy to measure with a protractor. The width of the tool, very straightforward, and the tip radius. So enter these parameters, and when you're happy and you like it, let's call a manufacturer myself. Okay, and then we hit this checkbox. Okay, and it goes back to the start window. If I come back here to this tab, there's my custom tool. And by default, it puts it as available and a medium priority. You can change this if you like, up to you. Okay, so that's the first way. Let's go back to here. Just so you know, all these are very similar. If I do a gooseneck, it's going to have a few more parameters that you'll have to answer, as you can see. As you highlight them, it'll indicate what that geometry is on the actual visual diagram here, or the drawing. So use that for your reference. Okay. Now these will typically handle most goosenecks. Okay, but very unusual ones, you'll get to a point where you just can't use these standard configurations to meet your needs, and that's where our custom punches and dies will come into effect, where we import a DXF file. So these will handle our basic shapes. Okay, I'm going to show you how we do a punch, how we do a custom one. Okay, I'm going to do, you'll see I have this one highlighted, but right from this area here is where I create a new one or import one. What I'm going to do is I'm going to select a DXF file, and like I mentioned earlier, my DXF file would be prepared already with the origin at the right point, and also ensure that it's the units are matching. Okay, if it's a metric configuration on your Vision, make sure that's the same on your DXF file. So what I'm going to do is I'm going to go ahead and load a file. So I'm going to go to this DXF file here, BIU 807. Okay, normally this is in the library, but this is the DXF I have. I can show you. I'm going to hit OK, and you see here it brings it in and it shows the representation of that tool. What we need to do is, with attach point, we're going to shift this, and you'll notice right now it's not proper. It's showing that it's bottom way at the top, and this surface clearly can't be up here. So because earlier I said we put our origin at this point here, I can easily find this location by simply putting 0 here, okay, and tabbing over. And you see my picture updates. Now it's oriented correctly. That makes this easier. If you don't have your origin in the right place, say if it's way over here or way over here, if you don't know these numbers, it's very hard to guesstimate. You'll be picking and choosing, and you're likely to make a mistake or have the wrong number in. So that's why we put the origin there. Makes this real simple. Bring it in at 0, 0, and it lines up perfectly. So with that graphic, or the DXF file brought in, I need to enter all the names here. Okay, I'm just going to make this different so I can delete later. We can tab through, answer all the questions. Okay, and these things that I'm putting in here are probably going to be used mostly just for filtering purposes. When you're looking at your tooling catalog here, you can filter, so you can put them in accordingly. Obviously you want to put in the numbers that you do have. Right now I'm kind of faking it. Okay, and we put in the type that it is. We'll say gooseneck. Tip angle, we'll say 80. Tip radius 0.039. So with all that information entered, okay, I just hit the plus button here, and that enters it into my library. And again, it checks the available checkbox, so by default, and set that to medium. So adjust these if you need to, and you have your custom tool in there, and you're ready to go. And that's it. Thanks.